So pre-algebra, hello and good day. Talking about CO31, we are identifying the X-intercept and Y-intercept of a line given an equation. And we're starting today's objective with the same two questions that CO30 ended with, which is, what is true about the order pair of every X-intercept? We just answered this moments ago, so hopefully it's still fresh in your mind. What is true about the order pair of every X-intercept? Pierce. Y will always equal 0 every single time. Okay. And then, what is true about the order pair of every Y-intercept? Maggie. X will always be 0 every single time. Okay. And those answers are important, since the above answers are important because it helps us understand why we do what we do when solving an equation for the X-intercept and the Y-intercept. Okay? Well, I'm going to leave these blank for now and skip directly down to this first one here. 3x plus 8y equals 24. If I'm looking for the X-intercept, okay, first of all, recognize that this is an equation, right? 3x plus 8y equals 24. How do we know that this equation can be graphed on the coordinate plane? What about that equation tells us that we can graph it? Aiden?
The fact that there's an X and Y.
The fact that there's an X and a Y, right? And so what we're looking for here is trying to figure out where this equation, where the graph of this equation is going to cross the x-axis without actually graphing it. Okay, by using what we know about solving equations to get that same answer. In CO30, we had the line graphed and we looked. Okay, here we're going at it from an equation. Now remember, in an equation that can be graphed, all the solutions for x and y represent ordered pairs that are on that line. So if we're looking to find the x-intercept, and we know that for every x-intercept, y equals 0, what does that mean we're going to do? To find the x value that makes this equation true when y equals 0. It means that we are going to rewrite the equation, but instead of y, what am I going to input instead? Aiden? 0. Right? Because what I'm looking for here is the value for x. Where is this going to cross the x-axis when y equals 0? Okay, so the equation gets rewritten with 0 plugged in for y. And what does that do here with this 8 times 0? Why do we love to multiply by 0 when solving an equation? What's the property of 0? Connor? Anything times 0 is 0. So this essentially cancels out, which is nice, because then all we're left with is this 3x equals 24. Right? And what value for x, when you multiply it by 3, gives you 24? 3 times what, Carly? 8. And we find that if we use opposite operations here and divide both sides by 3, which is how we would normally solve an equation, 24 divided by 3 equals 8. So the x-intercept of this equation, if we were to graph it, would be at 8, 0. And again, we got that by using that information that for every x-intercept, we know y will be 0, so we just rewrite the equation, but instead of y, we put a 0. Aiden?
So it says solve the equation for the X and Y intercept.
Yes, we're not done yet.
How do we is it going to be like ones where we have to solve for the Y-intercept in this?
Exactly. We solved for the x-intercept. Now we're going to go to the y-intercept. And knowing that for every y-intercept, x will always be 0, what are we going to do here to solve this? Connor?
8 times 3.
Sorry?
8 times 3. X equals 3.
X will equal 3. Yes, you kind of jump. But how we can get there, Leah? Exactly. We kind of do the same thing that we did to find the y-intercept, only this time because for the y-intercept, x will always be 0, we're going to rewrite the equation and replace x with 0. And so we get 3 times 0 plus 8y equals 24. That's why these two questions and the last objective and now here are so important, okay? Because for that x-intercept, just replace 0 with y, or replace y with 0 and solve. For the y-intercept, replace x with 0 and solve. Again, this is fun because 3 times 0 cancels out, and we're left with 8y equals 24. 8 times what number gives us 24, or divide both sides by 8. Either way, we get y equals 3. So the y-intercept of this equation is 0, 3. Okay? So, going back up to those two arrows up at the top there, to find an x-intercept, we're going to set y equal to 0 in the equation and then solve for x. Should make that look more like an x. There we go. Okay. Set y equal to 0 in the equation and solve for x. To find a y-intercept, you're going to set x equal to 0 in the equation and solve for y. Okay. This whole section here is a key point, which means that whole section there is eligible to go on a help sheet. Right? You can't put an actual example of us doing it here, but you can remind yourself of the steps in order to solve it. Okay? I'm going to scroll down the page so we have a little more space here to do our work. Does anyone else need these notes still? Okay. To find an x-intercept, set y equal to 0 in the equation and solve for x. To find a y-intercept, the second line, set x equal to 0 in the equation and solve for y. Everyone good? Ready to move on? Okay. All right. Let's look at the second one there. 5x plus 2y equals 30. Okay. To find the x-intercept first, we'll be setting y equal to 0 in the equation and solving. 5x plus 2 times 0 equals 30. We like this because that 2 times 0 cancels out, and we're left with 5x equals 30. Opposite operations to solve this, or this one probably do mentally. Divide both sides by 5 to get x by itself. X equals 6, which represents the x-intercept of 6, 0. Right? When we plug in 0 for y in that equation, the x value is 6. 6, 0 for the x-intercept. For the y-intercept, same kind of deal, only this time we'll be setting x equal to 0. Because for the order pair of every y-intercept, x will always be 0. So we have 5 times 0 plus 2y equals 30. That's 0 we like because it cancels that term out. 2y equals 30. Either mentally or by using opposite operations. Divide both sides by 2. And y equals 15, which represents the y-intercept of 0, 15. Okay. You do need to pay attention to signs. Okay. In that third one there, we have 3x minus 6y equals 42. When we go to that y-intercept, which means we're setting x equal to 0. So we have 3 times 0 minus 6y equals 42. We know this term cancels out, but then what's my next line going to be here? When I write my next line, after I cancel out that 3 times 0, what do I have left? Negative 6y. Remember that sign follows it. Okay, that sign belongs to that 6y term. So it's negative 6y equals 42, which means that when we divide both sides by negative 6 to get y by itself, 42 divided by 6 will give us a negative 7. So just watch out for those, just like we found with combining like terms and solving equations. We did that before. That sign, that subtraction sign, it belongs to this term. It's kind of attached to that term, so that when we cancel that 3 times 0, it's got to drop down and it becomes a negative 6y. Okay, for y-intercept of 0, negative 7. Right? Other than that, it's pretty straightforward as far as that process. Okay. Any questions so far, or one you'd like to do together that further on down the page looks to be a wee bit complicated? Samara? Sure, the last one. Okay, the last one, there are actually 2 of them in here. The first one in that bottom row and the last one that have decimals. Okay. If you're someone who doesn't like to work with decimals, what can you do to that equation that's going to eliminate the decimals and still give you the correct values for x and y? Yes. Sorry? 1.8 is not 8, right? This represents 1 whole and 8 tenths. Carly? If we round, it's going to take away some of the value. Rounding's not quite the way to go here. If we want to just get an estimate, rounding would be okay. But if we want to keep this the exact value, what can we do that's going to get rid of all those decimals and keep our values for x and y the same? Samara? We could go fraction forms, but if you don't like decimals, you probably don't like fractions either. Maybe you don't know this trick. Okay, so if you notice how those decimals are all out to the same number of places, they're all to the tenths. What happens to a decimal, like 1.8, when we multiply it by 10? What's 1.8 times 10? Maggie? It's 18. All multiplying by 10 does is it moves your decimal 1 spot to the right. So 1.8 times 10 is going to give us 18x. And since we multiply that 1.8 times 10, we also have to multiply our negative 0.4 times 10, which gives us what? Move that decimal 1 spot to the right. What do we get? Leah? Negative 4y minus 4y. And because we multiplied both of those terms by 10, we also have to multiply the 7.2 by 10. And what's 7.2 times 10? Move that decimal 1 to the right. Aiden? 72. And lo and behold, we have just eliminated the decimals. And because we multiplied each term, that's the key here, each term in the equation by 10, our values for x and y will not change. Okay, we've written an equivalent equation so that we can solve for x and y and still get the same answers that we would have if we kept those as decimals. But this makes it just a little bit easier. Okay? So in the other one, that contains decimals there. 1.5 plus 4.5 equals 27. What are we going to need to multiply each term by to eliminate those decimals? If you want to, you can certainly solve this as it is here. I mean, removing the that's not required. But if you wanted to, what would you have to multiply each term by to do it? Again, 10. Okay, even though that 27 is not a decimal, you still need to multiply it by 10, because if you only multiply the first two terms by 10 and not that other one, then your values are going to be off. Okay, so if you go that route of multiplying each term by 10, make sure you do it to that 27, even though it's not a decimal. All right. Any others that you would like to talk about of these first 9? We'll save the brain busters for a little bit. Yeah, Pierce.
So in number 7 with the decimal.
Yes.
If we multiply both of the decimals by 10, do we have to multiply the 27?
Yes. If you multiply one term by 10, you got to multiply them all by 10. And that goes for if you multiply one term by 100, you multiply them all by 100. Even though it's not a decimal, you're still going to multiply in order to keep that equivalent equation. And where is the decimal point in 27? Even though it's not written, where is it really sitting? Ifan? At the end, right? So when you multiply 27 by 10, you're still going to move it over one spot to the right. And what do we fill that empty space with? 0. So 27 times 10 is going to give us 270. Okay? Any others you want to talk about? Okay? And I've said this many times, and I'll say it again here. It goes back to that understanding that for an X-intercept, you're setting y equal to 0, and for that Y-intercept, you're setting x equal to 0. That is your key. That is your key. Okay. For the brain busters down at the bottom here, where I give you the x and the y-intercept, and you are writing the equation. It says write an equation with 7, 0, and 0, 2 as intercepts. How might you go about going backwards here now? Writing the equation. Any thoughts? Well, you may have noticed up above that in that first one that we did there with that 3 and the 8, that our Y-intercept, or X-intercept rather, was 8, 0, and our Y-intercept was 0, 3. There are some other, I'm looking for another example here, but I don't think I gave you one. I think that's the only one I gave you there. But what's kind of interesting about that relationship there? 8, 0, and 0, 0, 3 with the equation that we have. Well, I look at this and I see that, we have an 8 here and an 8 here, and we have a 3 here and a 3 here. Okay? The other equations aren't quite set up like that. I gave them to you specifically different way because I want you to kind of use this method to find it. But another example of one that's going to work out very nicely like this would be if we had something like 5x plus 3y equals 15. If you solve this to find the x-intercept and the y-intercept, you will find that the x-intercept is going to be 3, 0, and the y-intercept is going to be 0, 5. Not 0, 0, 5. Talking and writing today is not my strength. 3, 0, and 0, 5. Again, I look at this and I see that connection. We've got this 5 here and this 5 here, this 3 there and that 3 there. So there seems to be some sort of relationship between the x and y-intercept and an equation we could write that gets us there. So if I asked you, I'm going to choose different numbers than I have down below there, but if I gave you an x-intercept of 2, 0, and a y, is that what I have down below? I think it is. And a y-intercept of 0, 6, I think that's different, okay? I mean, take a look at the position of the X-intercept here and where it showed up in the equation, and take a look at the Y-intercept here and where it showed up in the equation. Wouldn't 6x plus 2y equals 12 work for this one? Right? Is that a TikTok answer or is that a hand up? Okay. I get confused between the two. So they are brain busters for a reason, that you have to kind of think about them, dive into them a little bit. But there is that connection, and we saw it with the first one here, and with the example here, and kind of working backwards like you need to do here. There is a relationship there between your X and your Y-intercept and the equation that you start with. Okay. Your homework for tomorrow is to finish the page. We'll stop recording. We can go over some more examples if you would like. But homework for tomorrow, finish the page. Anything else that you've got for me? All right. That's all I have for you. Don't forget to like and subscribe. Have a great day.